Welcome to today's webinar presented by HCL Software. This is the next in a series of several webinars we are currently conducting to help inform prospects, customers, and partners about some of the exciting things happening here at HCL and its newest product, the Volt MX development platform. We will now turn our attention to that phase in your digital transformation journey where you've reached that milestone of releasing your first app, or that second app, or perhaps a third app. But now you may find your dev cycle slowing down, occupied with numerous maintenance events that make it more time-consuming to keep the lights on rather than work on adding the latest new features users are demanding. Today we will see how Volt MX can help keep developers focused on innovation instead of getting bogged down by app maintenance. Just to recap, this series of webinars is covering a range of topics across the entire SDLC of how the Volt MX platform, using its low-code approach to application development, can help reduce project complexity, integrate back-end systems more quickly, maintain development velocity, and as we'll see today, as their application footprint expands, helps developers focus on innovation rather than maintenance. For our session today, we'll look at how our patented technology Volt Flare, our secret sauce, means you no longer need multiple code languages or even multiple code bases to create a tailored experience for the exact device or browser you wish to support. It helps to reduce the resource burden on keeping the lights on. It helps to future-proof your investment for upcoming versions of device operating systems and browsers, and allows you to harness all the device features you want to use to deliver the experience your users and customers expect. It uses just one set of JavaScript source code, thus reducing the overall maintenance and cost of ownership. On your digital transformation journey, every department today is having to supply apps and services, both internally and externally, to employees of their own and other departments or areas of the business. Each department or line of business will have their own app requirements to suit their business needs. For example, the apps may have to be device independent. In other cases, there is a device management policy in place that has additional security requirements and potential device hardware requirements, or even device restrictions. Others may follow a bring your own device or BYOD approach, and the company requires developers to include additional app security or leverage security techniques such as multi-factor authentication. Each app approach may have its own investment in a specific platform or technology that may not be surfaced to other teams. This produces a siloed approach to development and support without necessarily optimizing the available resources. For resource management, a department may have its own IT resources and budget, may develop its own applications, and therefore may have some specialized skills that other departments do not have. In other cases, some departments or organizations must either share or reach out to partners or third parties because IT does not have or have enough of the available resource skills needed. Under a single IT org, it can mean an IT engineering department has to maintain a larger pool of resources in order to handle support and development for all necessary product coverage areas. Now, in this scenario, every department has some sort of cross-functional activity with other departments, and this results in each department needing information from each other's systems. For example, sales, HR, and construction or engineering departments could be reaching the same devices and endpoints using information from each other's backends. If we actually get behind those applications and behind those users, what you see here is a simplified overall architecture whereby those same platforms, those same operating systems, those same integration services, those same architectures in the back end have to come through and support each of those departments. And we're touching multiple devices and endpoints all across the board. In a situation where you have multiple apps accessing multiple department backends, the support around this environment begins to spiral, creating additional demands of your IT organization. The support combinations begin to grow as the interaction complexity grows, as the number of apps grow that access the growing number of departments that begin to offer these platforms and services. The amount of applications that are essential for running the business also continues to grow, and this will impact the demand for resources accordingly. And then change occurs, as it always does. Those changes can be great business opportunities. It could be an example of where sales and marketing have now established customer demand for products and services in a part of the world where Android devices are now prevalently used, and hence they now need to be able to support the range of Android devices for their apps. Research departments may now have a series of projects in remote regions. They now require applications that must function offline, as they will likely be operating now in a disconnected fashion. Applications are not often converted from online to offline very capably in a very straightforward manner. This will require code changes at a minimum. This might also require a shift in application design. Developers may now have a new requirement provided by those sales and marketing folks because they added Android devices. So IT now needs to support the new Android operating system. They have another requirement from their research team to make their existing applications start to function offline, but they now may not have time to get to it for 6 weeks. Developer resources are impacted by having to plan for and allocate time to ensure their existing apps stay functional and working for these departments. This change environment essentially begins to look in a simplified way like this. As we covered in our previous webinar, you have your 6 app architecture layers or services in place to help build your solution, extend your enterprise functions to that solution, and then help manage them once they're all in place. These layers are represented by many solutions in the market, many logos available to choose from, and you can see some logos there, some best of breed, that will sit on top of their layer or layers and extend the backend SAP and Salesforce services, just to use 2 examples, out to those end users. Now, when you're discussing a native Android change, when you're discussing an HTML5 change, that is going to require developers. It will require source code, and it will require subject matter expertise, not only in development, but also subject matter expertise in testing, as well as support to keep those lights on as well. So let's look at some of the challenges our customers have seen in this manner. Take the case of a customer in the construction industry that performs refrigeration and HVAC system installations. These are those big industrial commercial installations that you see on the top of the big office buildings or warehouses. The company has to manage work orders, timesheets, and inventory. They have had apps in the past for these functions, but they recently implemented a new ERP provider that requires changes to their existing applications. They are also moving from enterprise-issued devices to a BYOD approach. The company needs an Android app and an iPhone app for work order processing for their contractor installers. They're going to the BYOD approach in order to save on hardware costs, and they understand they will see a greater range of devices to support because they are currently experiencing a rapid turnover of devices amongst their contractors. Guys break phones on the job all the time. This is a job site for a construction site, so accidents happen sometimes. And so they're constantly replacing their phones, and sometimes it'll be a different type. It'll be an iPhone 8, maybe an iPhone 10, etc. So they got to have apps that are resilient to these various operating system changes that they see out in the field. And then in the warehouse, the company also needs to track time clock entries on tablet devices for their personnel, as well as manage the parts and inventory on their trucks using these handheld Android-based scanners, which presents now even more specialized developer demands on the business. Another customer of ours is a logistics and shipping company located in the southeast US. They have a fleet of drivers and trucks with delivery routes and packages to track, and they need to be able to help automate the data processing in and out of their back-end systems. They had a very, very small developer team, and they needed to rapidly develop an offline capable app for both native iOS and native Android. They needed to enable it with GPS and turn-by-turn capabilities, have it sync with their enterprise backend, and then still be able to deliver this all in less than 6 months. Their app roadmap also included the need for back office and front office desktop web applications, as well as a second native app with additional features that would be difficult to deliver with their existing developer resources. Also, we have a customer who is an international applied technology company that specializes in engineered products and services that primarily serve the offshore energy industry. They had an internal surge in demand from their lines of business for more applications to support their day-to-day processes. Many of these app demands had started on mobile devices and were now being required to be used on both the desktop and on a mobile device to provide that seamless transition between them. Some folks could only use their devices when they're on the job because of device management restrictions, so they couldn't take their work home with them. And they wanted to be able to deploy a web version so that folks could still do their work at home in order to help be productive and stay productive. And so also, some of these applications also required offline access. And then naturally, every app is going to be required to undergo a thorough security review, which is always going to mean extra time being introduced to the development lifecycle for each application. And so because of this, these requests were piling up, and it was starting to take too long to deliver them. So the development team was also told they would not have any budget available to hire new developers at this time. So they were facing some challenges in trying to meet the demands of their business in order to deliver those apps. Now, I'd like to bring us back to the complexity of the app architecture that might be common to the organization, where we have the multiple layers with multiple solutions from the multiple logos, all working to bring and support that application to the lines of business. Now, if we apply this to the front-end landscape, you look at the various opportunities for solutions, but also with additional overhead and further resource demands. You have your example of a native application, so native Android, native iOS, where you'll now need an Objective-C or Swift Xcode expert. You'll need a Java or Kotlin expert, but also likely someone familiar with the different operating system versions, as well as the individual hardware differences. This is already adding complexity, as these sets of combinations should now also be tested for during the QA phase. Add further HTML5 or PWA applications or the latest developer framework, and you will also need specific skill development expertise, but also likely someone familiar with the various browsers, the various JS libraries, and the various development practices for those respective tools and frameworks. Multiple browsers, again, means multiple test cycles, and new frameworks may require a learning curve before real development begins. And now I want to focus on the various skills and resources we'll need to manage the complexity at hand about supporting those different devices and browsers. It doesn't matter which ones you choose to use. You're going to need that expertise. You'll need that specific development expertise. You'll need that specific testing expertise, that specific support expertise as the source code for each of these applications begins to grow. It'll become more complicated, and it have to touch each one of these devices and across departments in your organization. So how does Volt MX help address these challenges and help you focus on innovation and not maintenance? First, if we look at 5 years in the mobile space between the 4 major manufacturers, consider just from a software perspective now. This doesn't even cover hardware changes through that same time frame. If you look at the number of operating system major version changes, like iOS 10 to 11 or Android Gingerbread to Lollipop, for example, for your existing applications, you would likely have a code review to evaluate any changes needed to accommodate any new operating system APIs. You would need to prioritize and schedule those changes, plan for any downtime, code those changes, test the app releases, and then issue one or more updates. That's for every potential release here. So every one of these releases indicates a maintenance event that can only add time and effort to your developers' schedules. Often, certain critical bug fixes come in point releases. So adding in the amount of minor operating system version changes, this can add even more complexity to the landscape, more maintenance events, and again, this hasn't even taken hardware into account. So in that same time period, we were able to support all of those operating system maintenance events while only issuing 4 major version releases to our platform. Using the Volt Flare engine with its omni-channel and multi-OS support, we were able to not only keep the lights on for existing apps, but also add immediate support for new device and OS features. This takes a big burden off of the development team. For example, when Apple Maps was first introduced, or Bluetooth beacon APIs, or biometric support like Touch ID and Face ID, we were also able to make those available cross-platform whenever possible. We supported those on day one. This has helped our customers keep up with device and operating system maintenance events while enabling them to focus on innovation and features. So how does Volt MX enable our customers to deliver against the innovation goals they've outlined? When we look at Volt Iris, the logic is built using a visual interface and provides direct access to many device functions in a drag and drop fashion. Connections to services exposed by Volt Foundry's library of adapters are accessed in a drag and drop fashion. It's all generated as a single set of JavaScript, and the Volt Flare engine keeps it all running. Volt Flare is patented technology that provides the means to build your device and PWA code so that only the code for your iOS back buttons show up only in your iOS binary. It means you can reuse your components across your device applications, deliver a write once, run many capability. Your Volt Flare supports the latest operating systems so that when it comes time to upgrade, you have the confidence your app will work. Volt Flare provides the secret sauce to render true native UI at runtime so that your user experiences are true native experiences, and you can extend that experience to anything the device can offer. It takes the burden off of the developers to have to manage the number of maintenance events because it makes the code work on the targeted devices. And it works with the Volt Foundry middleware, absorbing those integration changes and keeping that development velocity moving forward. The complexity of managing those multiple pools of expertise also gets simplified into just a set of checkboxes. You take your application project, you pick your output, and you check a box. Just a set of checkboxes. You design the screens, you create the logic, you pull in your integrations, you select where you want your app delivered, on what devices, and the Volt Flare engine will run that code and deliver the output you need. Using a single set of code and a single tool set to deliver the apps you demand reduces the amount of code to produce because you're not having to write entire applications in device-specific code. It reduces the burden of developers having to carve out and plan for development cycles every time an operating system maintenance event occurs. It means that there's less time spent keeping the lights on and more time to focus on innovation. So how does Volt MX with Volt Flare deliver on this promise? Well, our HVAC installer was able to deploy their phone and tablet apps with fewer developers because using one set of common language code for their apps helped them support their BYOD initiative. They saved tens of thousands of dollars annually in hardware maintenance and support costs, and were able to reduce their equipment training costs as well. Their contractor employees can now stay productive more quickly when switching devices. Their warehouse apps run on a variety of tablet devices, so finding replacements isn't difficult. And they can now support the changes in operating systems when their field guys update their phones to the latest OS over the weekend. Our logistics company, with a very small developer team, was able to deliver both a native Android and a native iOS app with one set of source code that utilized location services, offline data sync, and GPS integrated turn-by-turn directions, and delivered it in just 3 months. More importantly, they were also able to support the application and the various maintenance events introduced by the device manufacturers in the past 3 years. Instead of focusing on maintenance, they have added several new features during that same time frame, including training modules and time clock management, and are now in the process of building 2 new desktop PWA applications. The ability for fewer developer resources to support many users is one of the benefits that Volt MX has provided them. Finally, our international offshore engineering customer was able to see significant development efficiency using Volt MX. Using the same set of developers, where they were seeing release cycles from 6 to 9 months, are now seeing release cycles of 2 to 3 months. Using Volt MX meant they didn't have to retrain their existing team to become PWA developers. They used the capabilities of the tooling to make it quicker and easier to build and deliver. This allowed them to not only deliver their current app, but also deliver 4 more applications in the same year. They were able to take their desktop native functions and build a PWA in less than 5 months, now available on both the desktop and phones, resulting in a user adoption increase of over 477% when they deployed into production. Yes, that's not a typo. 477%. Now that users were able to work remotely from home, they could access the application, that PWA, on their desktop and stay productive. They did not have to navigate an internal app store to get the latest version and then only be able to use it when they're in the office. They did not have to go through IT for an uninstall or reinstall update process. They could just now load it via a browser on their phones or desktops. And simpler code also meant less time for the security review, given that the Volt MX platform already had their core security requirements already covered. So that wraps up today's webinar. With that, we'd love to have you check out a demo of our product. Let's then get out our phones, use the camera to navigate that using that QR code that you see on your screen. Let's get in touch and let's find out how Volt MX technology using that Volt Flare engine can help transform your application journey to keep you focused on innovation and not maintenance. Thank you very much for spending time with us today. We look forward to hearing from you, and we hope you will come join us again on our next Volt MX webinar.